Okay. Hello everyone, hello students. So today we are going to study a topic called mole concept from the chapter Some Basic Concepts of Chemistry. So what we'll be covering under the mole concept is what is meant by one mole, what is an Avogadro's number, what is molar mass. So to do any calculations around mole, we need to know all these things, right? Okay, so let us start. Okay. So let us understand what is the need to use this term called mole, right? So where did this need arise from? Okay. So we all know from our younger classes that atoms and molecules are very small. They're very extremely small in size, right? And like even in like very small amount of any substance, the number of atoms are like very, very large, right? For example, I have just 1 gram of carbon. In that 1 gram of carbon, there will be so many atoms of carbon, right? Like millions of atoms of carbon, right? So that is why this need of mole concept arised, right? Okay, let us understand. Okay, so these in just one drop of water, there are 1.67 into 10 power 21 water molecules, right? So it's like quite confusing. Like how can we, in our calculations, we can use such large numbers, right? So that is where the need for this mole concept arised. Okay. Okay, so to deal with such large numbers, the scientists they invented mole, right? They invented this mole concept. Okay, so mole, it is just a number. So what is the number? Let us see. Yes, like 1 dozen, right? So we go to the market and we say, ki we want 1 dozen bananas. So what is 1 dozen bananas? That means that we want 12 bananas, right? Or 1 dozen eggs. So 1 dozen means anything 12. If I say 1 dozen cycles, that would mean 1 dozen. That means 12 cycles. If I say 1 dozen books, that would means 12 books only, right? So just like how dozen is like a quantity that is used to measure something, mole is a quantity. Like century means 100, right? So it is like we are denoting that 100 amount by a century, right? Similarly, one mole, this is very, very important, we should know, one mole is equal to 6.022 into 10 power 23, right? 6.022 into 10 power 23 atoms. One mole is 6.022 into 10 power 23. Okay, but we have given this number. Okay, but from where did this come? Like what is this mole and where did this number come from? Let us understand. Okay, so 1 mole is that much amount. So basically we know isotopes, right? What are isotopes? Isotopes are, they're elements which have, the same formula, but the structure is different. So let us understand. Carbon 12 is there, right? Okay. So in isotopes, the atomic number is same, but the mass is different, right? The atomic mass can be different, but the atomic number is the same, right? So we have carbon 12 isotopes. So the amount of substance, that means the mass of exactly, the carbon 12 atoms, like how many ever particles are there in this carbon 12 atoms, that is the number of mole. As it is written here, the amount of substance that contains as many particles as there are atoms in exactly 12 grams of carbon 12 isotope. So how many ever particles are there in 12 grams of carbon 12 isotope? So what does this 12 mean? This 12 means it is the atomic number of carbon, right? Okay, so carbon 12 isotopes, let us understand. Sorry, it is not the atomic number, it is the mass of carbon. Let us understand the mass of one carbon atom. This is the mass of one carbon atom. Okay. Mass of one carbon atom is 1.992648 into 10 power minus 23 grams. That is the mass of one carbon atom. The number of carbon atoms in 12 gram of carbon. So how do we find out the number of carbon atoms in 12 gram of carbon? Okay, so one atom, like in maths, one atom is this much. So in 12 grams, there will be how many atoms? So you do 12 divided by 1.992648 into 10 power minus 23, right? So it comes up to be 6.022 into 10 power 23. That is one mole. That is Avogadro's number. Let us revise it one again. So what is the number of, what is one mole? One mole is exactly as many particles which are there in 12 grams 12 grams of carbon 12 isotope, right? Carbon 12 isotope, 12 grams. Carbon 12 isotope, the mass is 12. This 12 represents the mass. The atomic number is 6 and the mass number is 12. Okay. So as many particles that are there inside this carbon 12 atom, which is 12 gram of this carbon 12 atom, is equal to 1 mole of any substance, right? So we have 12 grams, we are dividing it by 1.99264, that is into 10 power minus 23 grams. This is the mass of one carbon atom. So we get this Avogadro's number, right? This is 1 mole, right? This is Avogadro's number. Now let us understand. So anything, 1 mole of anything would have the same Avogadro's number, like 6.022 into 10 power 23 molecules. Even 1 mole of carbon, even 1 mole of ammonia, anything which is 1 mole, it would have like 6.022 into 10 power 23 molecules, right? Okay. So that is what we have to understand. So this is a question for you, that in 3 moles of ethane, if I have one, okay, so ethane is like a molecule which is C2H6. Here you can see the diagrammatic representation of ethane, C2H6. You will study more about this in organic chemistry, but I think from class 10th knowledge, you already know about ethane, right? So in 3 moles of ethane, what is the number of moles of carbon atoms? So this is 1 mole of ethane, right? So 3 moles of ethane would be how much? 3 into C2H6, right? So you need to count the number of moles of carbon atom. So here you can see there are 2 carbon atoms. That means 2 moles of carbon atoms are there. So the number of carbon atoms in 3 moles of ethane would be 3 into 2, that is 6. There are 2 carbon atoms in 1 mole, right? So, okay, so they're asking 3 moles. So 3 moles would have how many? Would have 6 carbon atoms, right? So you can just pause the video here and then you can see the answer. So in the next slide, I'm showing the answer. So 1 mole, as I told you, 1 mole contains, so what is the formula? Formula is C2H6, okay? So 1 mole of ethane, it contains 2 mole of carbon atoms, right? So 3 mole will contain how much? 6 moles, right? Yes. Okay, next is 1 mole of ethane. We know that it contains 6 hydrogen. So 3 mole will contain how much? That's right. 3 mole would contain how much? It would contain 18, right? It would contain 18 moles of hydrogen. Simple maths only we need to use here, right? So how did this calculation come up? It has come up from the cross multiplication, like 3 into 6, right? Divided by 1, that is 18 moles of hydrogen atoms, right? Now, 1 mole of ethane contains 6.022 to 10 power 23 molecules of ethane. So, 3 moles will contain thrice of that, right? Yes, 3 into 6.022 into 10 power 23. Very easy concept, okay? Now, let us move forward. So, we also need to know what is molar mass. What is molar mass? Molar mass is the mass of 1 mole of a substance. Anything which is 1 mole. Like if I say 1 mole of carbon atom. So 1 mole of carbon atom, what is the mass of that 1 mole of carbon atom? That is called the molar mass, right? Okay, if I say 1 mole of nitrogen, so what is the mass of 1 mole of nitrogen? That is the molar mass, right? For example, water. The molar mass of water is 18.02 grams per mole, because 1 mole weighs 18.02 grams per mole. Similarly, molar mass of 1 mole of sodium chloride is 58.5. Now, how did this come up? Let us see. So the formula of sodium chloride is NaCl, and we know that 1 mole of, okay, for this we need to learn the periodic table, you need to learn the masses, right? So 1 mole of sodium, it weighs 23 grams. 1 mole of chlorine weighs 35.5 gram. If you add it, you get 58.5 gram per mole. That means 1 mole has 58.5 grams of sodium chloride. Okay. Okay, now can you calculate, this is a concept test for you all, can you calculate the molar mass of H2O, carbon dioxide, CH4? I'll do one for you. I will do carbon dioxide for you. So how will we do it? What is the mass of carbon? Yes, it is 12. Okay, what is the mass of oxygen? Good, it is 16. But since there are 2 oxygen atoms, we will do 16 into 2, right? So that will become 12 plus 32, which is equal to 44. So it is 44 grams per mole. Similarly, you need to do it for H2O, for carbon dioxide, and for methane, right? So that is molar mass, okay? So here you can check answers, right? So answers are given over here. Let us move forward. Okay, calculate the number of oxygen atoms in 4.4 grams of carbon dioxide. Okay, so okay, 44, just now we had found out the molar mass, right? So let us look at the answer. See, the number of moles. Firstly, we find out the number of moles. We know that 44 grams is 1 mole, okay? 44 grams. That is the molar mass of carbon dioxide. So we know that one molar mass is equal to the mole, right? That is 1 mole. So 44 grams of carbon dioxide is equal to 1 mole, right? So they have given us 4.4 grams. So 4.4 grams would be how many moles, right? So you do like a cross multiplication. So 4.4 into 1 divided by 44, which is nothing but 0.1, right? 0.1 mole, right? So if 1 mole, now quickly tell me that 1 mole has how many atoms? 1 mole has how many atoms? That is the Avogadro's number of atoms, right? Which is 6.022 into 10 power 23. Okay. So 1 mole has this much. So 1.1 mole has how many atoms? So you just multiply 1.1 with 6.022 into 10 power 23, right? Okay. So here you can see that 1 mole of carbon dioxide contains this much. Okay, so they're talking about atoms of oxygen. So there are two oxygens, right? Okay, calculate the oxygen atoms. So what I told you was for calculating the atoms of carbon dioxide. This is calculating the number of oxygen atoms. So since there are two, so there are 2 moles of oxygen, right? So these moles of oxygen would have 2 into 6.022 into 10 power 23 atoms of oxygen, and 0.1 mole we are multiplying by 2. Why? Because there are 2 atoms of oxygen here, right? That is the reason. So we get 12.044 into 10 power 22 atoms of oxygen. Let us move forward. Okay. So the next topic is percentage composition, right? Percentage composition, which is percentage composition of elements. Let us understand the percentage composition. So just like how we calculate the percentage of a marks. For example, I got 10 marks out of 20. So how do I calculate my percentage? That is 10 by 20 into 100, right? So that means that I got how much? 10 by 20. So you say 10 by 20. So I would just, multiply it and it would come up to be 50%, right? It would come up to be 50%. So I do 5 times and 5 into 10 is 50%. So I got 50% of marks. Similarly, I can calculate the percentage composition of any element, right, in any compound. For example, I have, let show it to you. Okay, for example, I want to calculate the mass percentage of copper in copper sulfate dot 5H2O, right? So what will I do? I want to find out the percentage of only copper, right? So mass of that element, what is the mass of copper? It is 63.5, okay? Then the mass of entire compound is 249.5. Then obviously, if we are calculating the percentage, we multiply it by 100, so you get how much? 25.45%, right? Okay. Next, if I want to find out the mass percentage of sulfur, only sulfur, that means I will take the mass of sulfur, that is 32, divided by the total mass of the compound, that is total mass is how much? 249.5, and obviously I multiply it with 100, right? Similarly, you can find out for oxygen. So why it is 144? It is 144 because there are 4 oxygen atoms, right? That is the reason. Okay, so there is yeah. So 4 and then 5 into 0. So I 5 into O. So the total 9 oxygen atoms are there. That is the reason, right? So 9 into 16. Okay. So now let us move forward. So this is a question for you. Calculate the mass percentage of each element in ammonia. So please do it. Calculate the mass percentage of each element. The ammonia, I'm giving you the formula. The formula is NH3. So you need to calculate the mass percentage of each element. Okay. So let me do one for you. Let us do nitrogen. So what is the mass of nitrogen? It is 14. And what is the molar mass? That is of this compound. That is 14 plus 3. Right? Why 3? Because there are 3 hydrogen atoms and 1 hydrogen atom weighs 1 grams. So it is 17 grams. Okay. So 14 by 17 into 100. Right? This would give you the mass percentage of nitrogen. Right? And I think you can do the calculations. So just pause the video, take a minute and just solve this. Okay. So the answers are given to you here. It is 82.35%. Right? Okay, so here you can see the percentage composition. So this is the topic of percentage composition, very easy calculations. Now we move to next topic, that is stoichiometry and balancing the chemical equation, right? Finding out the limiting reagent. Let us understand. Okay. So this is what we are going to learn, balancing of chemical equations, stoichiometry, the calculations, right? And the limiting reagent. Let us understand. So first, before doing any calculations regarding stoichiometry, stoichiometry is something that we are going to use to calculate the limiting reagent. So before doing any calculations, it is very important for us to balance any chemical equation, right? This you have learned in class 10th, right? So balanced chemical equation means that the number of atoms of each element on the left and right side should be equal. And why is it necessary to balance? Because any chemical equation needs to follow the law of conservation of mass. And can any one of you tell me what is law of conservation of mass? It says that elements and mass, right? It can neither be destroyed and nor be created, right? So suppose if this is my reactants and this is the product AB, right? So my equation is not balanced because here I have two atoms of A, here I have just one. So I need to balance it. So what do? I put two here, but still it is not balanced because I have just one B on the left hand side and right hand side there are two AB. What does this 2 mean? This 2 means there is 2 times A and 2 times B, okay? So now I need to make it 2B to balance my equation. So it will become 2B, right? Now my equation is balanced. So we need to check always that our equation is balanced so that it follows the law of conservation of mass, which is mass can neither be destroyed nor be created. If our equation is not balanced, so the rest of the calculations will go wrong. So please make sure that your equation is balanced. Okay, how to balance a chemical equation? So I think this I don't have to tell you because this we have studied in class 10th. But still, let us quickly go through it. We follow a method that is known as the hit and trial method. So what do we do? Basically, we start, balancing, and we start with the element, we prefer, so start balancing by any element, but prefer the main element, okay? Let us see here, carbon. Okay, can we see, okay, is carbon balanced here? No, the carbon is not balanced here because here there are two carbon atoms, here there's just one. So I put two here, okay, it becomes 2CO2. Now let us see the other elements if they are balanced, right? Let us check hydrogen. So here there are six hydrogen atoms and here there are just two. So what do? I put three here. So now you can see there are six hydrogens and six hydrogens. Hydrogen is balanced. Let us check. So we keep on repeating the step until all the elements are balanced. Okay. Now let us check for oxygen. So here there are just two oxygen atoms and here there are four plus three, seven. Okay, there are seven. But here this is O2. So I cannot put seven. If I put seven, it will become 14. So what do? I do 7 by 2, right? So now, if you don't want, see, we don't want our equation to be in the form of a fraction. So what do? We multiply the entire equation with 2. If we multiply it, this 2 and 2 will get cancelled. What we will get? 2C2H6 plus 7O2 gives 4CO2 plus 6H2O, right? Now you can check our equation is balanced. Okay, let us move forward. Let us move to stoichiometric calculations. Now, what is stoichiometric calculations? They are, for example, burning of methane. Okay, so methane is like a common greenhouse gas. So methane, we burn it with oxygen, we get carbon dioxide and water. So combustion of any hydrocarbon would always give you carbon dioxide and water. So first we write down the balance equation. Okay, let us check if the equation is balanced. Yes, but there's one carbon atom here and there is one carbon atom here. Okay, there are four hydrogen atoms here, there are four hydrogen atoms here, there are four oxygen atoms, and here also there are four, like two here and two here. It is balanced. Now let us check the coefficients, okay? That means one, okay, so coefficient, this is 2. What does this 2 mean? It means that there are 2 moles of oxygen. So there is 1 mole of methane combining with 2 mole of oxygen, combining with, giving us 1 mole of carbon dioxide and 2 moles of water molecule, right? So this is the stoichiometry, okay? This is the stoichiometry. Yes, okay. Okay, let us understand here. So one molecule, right? So if there are two molecules, suppose if there are two molecules of methane, then I have to multiply everything with 2. If I take 2 molecules of methane, then I'll have to take 4 moles of oxygen, and then I'll get 2 moles of carbon dioxide, and I will get 4 mole of water molecule. If I take 2 moles of methane, okay? Now let us understand the masses. Let us calculate the masses. Stoichiometry means everything has to be in accordance with the given equation. It is not like you cannot say that, a half mole of methane is reacting with 1 mole of oxygen. No, everything has to be in accordance with the given equation. So suppose if I give you 1 mole of methane and I give you the equation and I ask you that tell me how much amount of water will be formed. So you will say that 2 moles of water will be formed, right? So 2 moles of water, how will you find out what is the mass of 2 moles of water? You know that 1 mole of water weighs 18 grams and 2 moles will weigh how much? 2 into 18, that is 36 grams, right? Okay, let us look at the next example. Okay, let us do it together. Calculate the amount of water, okay, amount of water produced by the combustion of 48 grams of methane. So what do we do? First, we write down the balanced equation, obviously. So the balanced equation is CH4, right, plus 2O2, right, which gives us carbon dioxide plus 2H2O. So I think the equation is balanced now. Let us write down the stoichiometry. 1 mole of methane reacts with 2 mole of oxygen to give 1 mole of carbon dioxide, right, and 2 moles of water molecule. But now let us see how many moles of methane are there, okay? So moles is equal to given mass by molar mass, okay? So I have 48 grams of methane. What is the mass of 1 mole of methane, right? So 1 mole of methane, that is the molar mass of methane, would be carbon, that is carbon, the mass is 12 plus 1 into 4, so which is 16 grams. Okay, so I divide 48 by 16 grams, right? So let us calculate and find out that, it is coming up to be how many moles, right? So you can do a simple calculation. We divided by 4, okay? So 4 ones are 4, 4 twos are 8, 4 fours are 16, right? So this is how much? It is 3. You're correct. So we are getting 3 moles of methane, okay? Now everything goes in accordance with the stoichiometry. See, if there are 1 mole of methane, so I will write it here. 1 mole of methane is giving to me how much amount of water molecule? See, 2 moles of water molecule, 2 moles of H2O. But now I have 3 moles of methane, okay? 3 moles of methane. So 3 mole will give me how much? Yes, you're right. It will give me 6 moles of H2O. Right, right, right. So everything goes in accordance with this stoichiometry that we have written over here. So 1 mole of methane will give 2 moles of water molecule only. So if I have 48 grams of methane, first I convert it to the number of moles. So 48 grams would give me 3 moles. So 3 moles of methane would give us how much amount of water molecule? That is 3 into 2, 6 moles of water molecule. And you know that 1 mole of, just now we did it. Can you tell me the mass of 1 mole of water molecule? Yes, it is 18 grams, right? So 6 moles would be how much? So you just multiply 6 into 18. That would give you the answer. Let us check the answer. Okay, so you can pause the video, do 6 into 18. So let us check the solution. So first we start by balancing, that we did. Okay, so we know that 68 grams of methane, that is 1 mole, produces 2 moles of water molecule, right? So 48 grams would produce how much? 48 by 16 into 36, right? So this is a direct method, but we should always, find out the number of moles. You can do it this way also, right? So we can solve this, or you can do 6 into 18, right? 6 moles into 18 grams, okay? So if you can solve this, you will get the answer. That is 6 into 18 is also how much? 108 grams of water. Okay. So this you all can also try. You all can try this as a homework, okay? That calculate the amount of carbon dioxide that could be produced when 2 moles of carbon is burnt in air. So basically, I would just give you like a short hint. So carbon I have oxygen and it is giving me carbon dioxide. And my equation is now balanced, okay? Right? So they are saying calculate the amount of carbon dioxide produced when 2 moles. So this is 1 mole and this is 1 mole and this is also 1 mole. That means if I burn 1 mole of carbon, I get 1 mole of carbon dioxide, right? So if I burn 2 mole of carbon, right? If I burn 2 mole of carbon, I get 2 moles of carbon dioxide. And you already know that, 1 mole of carbon dioxide weighs 44 grams. So 2 moles will weigh how much gram, right? That is 88 grams, right? So you can find out the answer, that is 88 grams, right? Okay. Now let us come to our next topic, that is limiting reagent. Okay, what is limiting reagent? Let us understand. Limiting reagent is something, that limits the reaction. Okay. So how do we find out the limiting reagent? Similarly, write the balanced equation, calculate the moles of each compound, then we calculate the ratio. Let us have a look at the problems. Okay. Okay. So yes, just a minute. Yes. Let us look here. We have a balanced equation, nitrogen, hydrogen giving us ammonia. Yes. So what is the limiting reagent? Limiting reagent is something that limits the reaction. Okay. So let us find out. The weight given to us was 50 kilograms, and the molar mass of N2. Now here it is N2, not N. So molar mass is 28 grams. That would give us 17.86 moles, and moles of hydrogen are how many? 4.96. Okay. Now, like the stoichiometry is how much? We need to calculate as per stoichiometry, right? That it is nitrogen and moles of hydrogen, they are always in 1:3 ratio. They have to be in 1:3 ratio, right? Okay. So if you would see, they have to be in 1:3 ratio. So you can see that after dividing by 3, this is coming to be 1.653 into 10 power 3, which is less than 1.786. So 1 mole, this has to be 1:3 ratio. So if this, like if the amount of nitrogen is 7.86, then the amount of hydrogen should have been like 7.86 into 10 power 2 into 3 moles, right? But it is less. It is 4.96. It is less. It is not thrice. So if I divide it by 3, I should have gotten 17.86, but it is less. So that means hydrogen is getting finished first, right? It is getting finished first. So we will say that hydrogen is the limiting reagent, right? So here we have touched the concept of limiting reagent, in the very beginning, a very small part of it. So when we connect together through Urban Pro, we will, study it in detail from the very basics. Here I have just told you very quickly how to solve this question, right? So here hydrogen is the limiting reagent. Okay. So this is the end of our class. I hope you understood what is meant by. So let us summarize. We studied about mole, what is 1 mole, right? And then we understood what is molar mass, right? And then we talked about the percentage composition, right? Percentage composition. And then we started with stoichiometry. Yes, stoichiometry, and then we learned about a little bit about the limiting reagent, right? Okay. So that was it for today's class. And if you want to connect with me through Urban Pro. So you can connect with Urban Pro. So we can study all of these topics in detail and do lots of NCERT questions, right? If you have any doubts, you can put it in the comments, right? Thank you.